A traverse survey is a type of control survey which involves the establishment of a series of points that are linked together by lines to form a framework. The series of straight lines that connect the successive points are called as traverse lines. The ends that define each traverse line are called traverse stations or traverse points. The framework formed by connecting survey lines of known length and direction is called a traverse. In the figure, ABCD forms a traverse, where AB, BC, and CD are traverse lines, and A, B, C, D are the traverse stations. In traversing, the surveyor moves from one point to another by simultaneously measuring bearings and distances by dead reckoning. Dead reckoning is the process of calculating current position of some moving object by using a previously determined position. It is employed when the construction work is long and narrow. For example, tunnel or motorway construction. The main objective of traverse survey is to establish horizontal control in land areas, especially in areas where the line of sights are short due to heavy built-up areas, where other survey methods like triangulation and trilateration are not applicable. The main objective of traverse survey are to locate or establish boundaries, to achieve horizontal control for topographic survey, to locate and prepare construction layout for highways, railways, and other private and public works, and to conduct ground control surveys for photogrammetric surveys. The two types of traverse encountered while conducting surveys are open traverse and closed traverse. Open traverse is a traverse that starts at a point of known position and terminates at a position of unknown coordinates. In the figure, A is a point where the traversing starts, whose coordinates are already known, and F is a point where the traverse ends and whose coordinates are unknown. An open traverse is suitable for surveying along a narrow strip of land. For example, for surveying roads, railways, canals, rivers, coastlines, pipelines, etc. An open traverse can run from few hundred meters to kilometers. The consistency of angles and distances cannot be measured or checked in the case of an open traverse. So whenever you need to check the measurements taken, you need to repeat the process of measuring distances or measuring the angles. Closed traverse. Closed traverse originates at a point of known position and closes on another point of known horizontal position. Now, a closed traverse hence can be a closed link traverse or a closed loop traverse. In a closed link traverse, the traversing starts at a particular point whose coordinates are known and ends at a particular point whose coordinates are also known. If ABCD is a closed link traverse, A and D coordinates are already known. In case of closed loop traverse, the traverse starts at a known position and ends at the same position, so it forms a loop. A closed traverse is suitable for locating the boundaries of lakes, houses, gardens, and for large areas like towns, residential campus, etc. Unlike the open traverse, a closed traverse lets to have computation check that will help to understand or estimate the errors that are being formed during the surveying process. It can be determined both for distance measurement as well as angular measurements. What is the procedure to perform traverse survey? The steps involved in traverse survey are reconnaissance, selection of traverse station, linear and angular measurements. Reconnaissance is defined as preliminary field inspection of the entire area that needs to be surveyed. This involves the surveyor going to the field and checking the entire area. He decides the best plan for working. He checks the intervisibility of the traverse stations. He decides the method of traversing to be adopted. Based on the method chosen, the instrument and accessories are selected accordingly. Selection of traverse station. The basic principle followed in surveying is the working from whole to part, and that is adopted. Minimum number of traverse stations should be selected while doing this process. Take the length of traverse line as long as possible to reduce the time and centering effect of stations. Try to select stations on a level and firm ground. After selecting the station, mark them using pegs. Step 3 is linear and angular measurements. The distances between the stations are measured using a tape or a tachymetric method or EDM instruments. The angular measurements are done using a compass or a theodolite. The traverse lines are determined either by direct measurement, indirect measurement, or angular measurement. Direct measurement involves tapes and EDM, electronic distance measurement devices, indirect measurements like tachymetric methods, and angular measurements like theodolite or compass surveying. Whenever there is a change in direction of traverse, an angular measurement is necessary. The traverse survey is performed by a traverse party and a traverse equipment. Traverse party consists of an instrument operator, a head tape man, and a rear tape man. Traverse equipment is used for traverse survey, which includes theodolites, compass, tapes, chains, tachymetry, hand level, leveling staff, ranging pole, plumb bobs, EDM and reflector, stakes and hubs, tags, marking crayons, points, walkie-talkies and hammers, etc. So the instrument that is used for traversing is dependent upon the method of traversing that is employed, which is actually selected during the reconnaissance period of this particular site. Hope you like this video. If you need more civil engineering technical videos, kindly subscribe to our channel Civil Engineering Fanatics.